angiogram is the basis for the assessment of calcification. And these are the definitions. The definition is moderate calcification is angiographically calcium seen only during cardiac motion on one side of the vessel. Moderate to severe is seen only with, but not without, cardiac motion on both sides of the vessel. And finally, severe calcification is seen without cardiac motion on both sides of the vessel, okay? And you'll see in the title, I labeled this antiquated angiographic calcification. I don't know any interventional cardiologist on earth who actually does that. Nobody takes their foot off the pedal to see if it's still there, and if it's not there, it's completely antiquated. And really what we do is this, right? If it's on one side of the vessel, we think it's moderate, and if it's on both sides of the vessel, we think it's severe. One side is eccentric, both sides is concentric, and we make our plan. Nobody's taking their foot off the pedal and, you know, doing any kind of other analysis on this. So that's the way we should be thinking of calcium, is eccentric or concentric, because they have very different treatment results. Now, this is angiographic calcification in 2024. This is device detection from Philips. So if you have Sync Vision, this comes with the Sync Vision. It's free. Once you've purchased it, it comes on automatically. And 90% of the problem is that nobody turns it on, okay? If you turn it on, it actually shows up on the screen automatically. But maybe you're not turning it on because you're not seeing the value. Let me show you the value of what this has on it. Okay, on the side, where moderate eccentric, you can see that there's calcium only underneath on the bottom side of the image. For severe calcification, you can see concentric calcium, meaning calcium on both sides of the balloon, but also you can see that there's segments mixed in, which is real life, of eccentric. So there's both concentric and eccentric calcification. And finally, on the right side, you can see the one other thing that we're very interested in, and that's nodular calcification, because the response to therapy is terrible and the patient outcomes are terrible. Now, all X-ray systems come with one of these tools, and these tools are designed for angiographic enhancement. You can have Clear Stent from Siemens, Stent Visit from GE, Stent Boost from Philips, Stent Boost Live from Philips, and device detection from Philips. And so what these do is they're designed to let you see the stent so that when you post-dilate, you don't end up coming outside the stent. But there's one thing that you see on every single slide, and that is also the calcium. Okay, it easily detects the calcium. You can see calcium on the Clear Stent that's eccentric. You can see it on Stent Viz. You can see that they've landed the stent edge into plaque, into calcium on the Philips Stent Boost. And finally, you can see very eccentric calcification on the Stent Boost Live. So why is that important? The reason is, in regular X-ray, right, you pick up calcium in 40% of cases. On intravascular imaging, you pick up calcium on 84% of cases. That's not a small gap. That's a doubling of detection of calcium. So either something is too sensitive or it's too specific, right? And we want something that's sensitive and specific. So let's think about this for a second. When you look at angiographically severe calcification compared to none, mild, or moderate, only angiographically severe calcification predicts stent under expansion. Severe calcification is concentric. So we need to be able to identify that. So the angiogram is definitely the gatekeeper. You don't pull out an intravascular imaging case if you don't see calcium to do a calcium-guided therapy. What would happen in that case is that you find calcium incidentally. That's the 40% of cases where you can't see the calcium on angiogram that you actually end up seeing it on the intravascular imaging. So why do you need advanced angiography? Well, one of the things is, for shockwave in specific, you need to know exactly where the emitter is. Okay, this is a really poorly understood phenomena, and let me prove it to you. Okay, this is how we ordinarily do angioplasty. We put the tightest segment in the middle of the balloon, and then we inflate it as high as we can until it yields. That is not the way you should be doing shockwave, okay? Because the analogy is, you have a gun, and you've decided to take 2 steps to the right from your target and shoot straight, okay? It makes no sense. if the gun is the emitter needs to be right on top of the calcium. And in this case, it's not. We're completely missing it. So our emitter placement is very important. And you cannot easily see the emitter on regular fluoroscopy or x-ray. You need to use advanced techniques. Stent boost, clear stent. My favorite is device detection because it's live in fluor and it doesn't even cost you more radiation. So remember this placement of the IVL balloon. Your first emitter is 2 millimeters from the proximal stent marker. Then you have a 6 millimeter gap, and then you have a 4 millimeter gap. And the reason is not 3, 3, 3, and 3 is so that you can get the front edge of the balloon into the lesion. Okay, remember the thickest part, of course, is where the emitter is. So there's your emitters. So understanding where your emitters are on the balloon is the first step, but literally co-locating them over the calcium is an even more important step. And here's an example of us doing this in our lab, okay? So what we've got is a piece of eccentric calcium, and we're moving it on the device detection until we've got it immediately across from the emitter, all right? And now watch what happens when we get it right across from the emitter and fire. You can actually see the calcium break on the x-ray, right? So this is way past intravascular imaging. You can see that you've prepped the lesion on advanced fluoroscopy. Okay, what else can we learn? Let's think about feature detections on advanced x-ray. What do you learn from this image? You learn that there's no nodular calcification, there's short